Okay.
0.483.
Yeah, you're good.
Welcome back. Can you hear me out there? Excellent. Now, so the brown, those are the constants. Those will be given to you tomorrow on the quiz. The red is what's given. And it's easy. You have to interpret the word problem and then put the givens in the data table and put the correct unit labels in. Correct? Okay? All right, now. You have a copy of the equation sheet? Now, this is the first thing we're going to do. Okay, you see that? Did that come up on the machine?
This way. There you go.
All right, this is a copy of what's going on. Down here in Q1, down here, you're going negative 25. Up here, is that right? You're going to 125, correct? Am I pointing to the right place, Laura?
Yes.
Okay? Right now, this is what I want to do. This is the first thing I want to do, and I'll do this on camera, okay? I'll use purple for temperature, okay? Now, the ice is going to gain energy. And it's going to go from negative 25 to 0. That'll be Q1, right? The initial temperature is negative 25. The final temperature is 0. And then it will go Q2 will be the heat of fusion. The beginning temperature is 0. The ending temperature is 0. Okay? You follow me? So, this is what I want to do. You see where it says temperature, initial temperature Q1, initial temperature Q2, initial temperature Q3 for the ice? That's what I want to fill in. Okay? So this is what I want to do. I want to know each transition. Do you understand that the ice is going to go from negative 25 to 0, 0 solid to 0 liquid, 0 liquid to 70 Celsius, right? Q1, Q2, Q3, right? Steam is going to go from 125 gas to 100 gas, 100 gas to 100 liquid, 100 liquid to 70 liquid, right? Okay, so I want to know final temperature, initial final. I'm sorry, final temperature, initial temperature, okay? All right, now, Q1, final temperature, initial temperature. Q1, final temperature, initial temperature. But what's the initial temperature of Q1? Negative 25, right? Final temperature? 0. All right? Q2 is going to go from 0 solid to 0 liquid. Initial temperature, final temperature, initial temperature. Why am I saying final initial instead of initial final?
Because you're starting from...
Because delta T equals final minus initial. That's all. That's the only reason I'm saying that. Trying to get you used to that, the way it works. Okay? Anytime you see a delta, it's final minus initial. Okay? Q2, what's it going to be? 0, 0, right? Right? Okay? So this will be okay? So far? Q3, ice. Final? Final. It's going to be the final in the Q3, that middle range, when it's liquid. What's the final temperature going to be? Look at your chart. Look at the question on the board here. Look at the question, look at that chart. What's the final temperature of Q3 ice going to be? They're thinking. Let's give them a moment. What is it?
100?
No. The ice.
What is ice?
What's the initial temperature going to be in that Q3 in that middle region?
I don't know.
I don't
I
know.
have no idea. I don't
Give it to me.
comprehend.
Give it to me. Can you see this, Laura?
Go up a little.
Can you see this?
Yeah.
Is that all right?
Yes.
So you're going to go, this is the initial,
Uh-huh.
that's 0, right?
Yes.
And isn't that the final? Is it going to go to 70?
Oh.
So
Okay.
final is 70, initial is 0, isn't it?
Yes.
Isn't that right?
Correct.
Okay. So the ice, Q2 it's melted. Q2 it's 0 Celsius, liquid. Now it's going to warm up to 70 and we're done for the ice, correct?
Mm-hmm.
Final temperature 70 degrees. So I'll do purple. Getting a little crazy with the markers, okay? 70. And the initial is what?
0.
Okay? Now the steam. Let's start with Q5, okay? Final temperature.
Q5.
Yeah. Where's it starting? Where's it?
It starts at 100.
No. That's the final temperature. In other words, it's up at 125 degrees, right?
So that's the final then?
So,
Come here. Yeah, final is 100. Here, give it
so
to me.
this is the final?
Yes.
Oh, so that's for that?
Yeah, in other words, look. No. This, can you see this?
Yes.
Okay, look. You see this? Can you see it?
Yeah.
Yes.
Okay. That's 5. That's Q5, right? This is 125, right?
It's
So
120.
it's 20.
125.
Yeah.
Yeah, it says 120 there, but relative to the problem,
Okay.
it's 125, right?
Yes.
So the initial is 125. It's going to cool to 100.
So 20.
So the final temperature is 100. The initial temperature is 125.
Okay.
You see how you have to think? This isn't state capitals.
Okay.
Okay. The capital of Latvia is
Riga.
Riga. Yes. Doesn't do a bit of good for you, does it, in this? You got to think.
Okay.
Okay? So, initial temperature, final temperature. Final temperature is 100, right?
Yeah.
Initial temperature?
125.
Wait.
No, initial
Yeah.
temperature is 125. Sorry. This is 125.
And then final
And
is
final temperature is,
100.
100.
all right, now, it's 100 degrees gas. What's it going to do?
What do you mean?
Look at the graph. It's 100 degrees gas. What's it going to do?
Is it?
It's 100 degrees gas. Think. Think. It's 100 degrees gas, right?
Yeah.
This is number 4, Q4. It's 100 degrees gas,
Yeah.
right? What's it going to go to? 100 degrees liquid, right?
Yeah.
So initial temperature is 100 degrees. Final temperature is 100 degrees, right?
Yeah.
Correct?
Yeah.
Okay.
It goes to liquid.
So this is 100 degrees. This is 100 degrees. You know, do we need to worry about a change in temperature for heat of vaporization and heat of fusion?
No.
Absolutely not. I simply want you to be able to think of it though.
Okay.
This is, we're trying to think our way through this. This chart, you can't fudge this chart. If you don't understand it, you'll never figure it out. Okay? Yes? Okay. Where are we? All right. We're at 100 degrees liquid. Where are we going?
Yes.
We're going to where?
Yeah.
Are we going back?
Yeah, we're going from 100, we went from 125 to 100 gas, now 100 gas to 100 liquid, now where?
So.
What are we doing? You got to go back and think. What are we doing?
So you went from.
We're going to 70. Aren't we going to, now we're going to 70? We're going to 70, right?
Yes.
70 liquid, right?
Yes.
We're going from 100 liquid to 70
70,
liquid, and that's the
yes.
final temperature, right?
Yes.
Isn't that what it says?
Yes.
Final temperature
Correct.
70?
Yes.
So the final temperature is 70 degrees Celsius. So this is 70 degrees Celsius. See how they're the same?
Yes.
Does that make sense?
Correct.
And that's what this one is too? You see that? Make sense now? A little
Yes.
better?
Yeah.
Yeah? And what was the initial temperature?
100.
100. And that is here.
Make sure you're going up.
Okay? You get it? Yes?
Yeah.
Okay. Now, let's turn off the projector. I'll write some equations on the board. I'll write some equations down. I'll do some calculations. We'll come back and we'll look at them, okay?